All right, guys, so we're going to be going through the soldering practice activity 0301. We're actually only going to be going through the first half of it. The second half focuses more on the SMD components. We'll be coming back to that whenever we're actually working with more SMD components in the future, most likely during next semester. But before we get started, I wanted to first show you the soldering iron itself. So right here, I have a Weller WE S51 soldering iron. And I want to just go over a little bit about all the functions that are on here. It's relatively simple. You have an LED here that indicates whether it's on or not. Whenever it is heating up, this light will be solid green, and whenever it reaches the temperature that your dial is set to, it will start blinking. There's your on and off switch here. Down here is where you connect your soldering iron itself, and then you have your dial for changing the temperature here. And on this one, you can go between 350 degrees Fahrenheit to 850 degrees Fahrenheit. I usually like setting it around 650. The other thing I want to show you here is the soldering iron itself. Now, one thing that you do need to pay attention to is you have to make sure that your soldering iron matches your soldering station. There are different styles of plugs on here, so before you plug it in and to avoid any damage, make sure that they line up properly whenever you're first connecting it. So I want to go ahead and connect this here. And then it twists to lock. And then often you should also have a small soldering station here. Here's a little sponge right here that I have wet so that I can wipe off any extra solder. And then this is the copper cleaning pad that Jill was talking about in the lecture itself. So I will put it in here, and I'm going to keep this a little bit off screen here. Now, one of the things I want to reiterate before I get really into this is soldering is a potentially hazardous activity. You can burn yourself. You can inhale bad smoke, and you can irritate your eyes from the smoke from the solder itself. So it is very important that you wear a pair of goggles and you keep it a good idea of where the hot stuff are and where all your wires are. Like, for example, over here, you couldn't see off screen, my soldering iron was actually touching its own wire, which is a very, very bad thing. And first things first, I wanted to also go through some of the different kinds of soldering, bad soldering tips here. And I've actually gone ahead and gotten a few examples of bad soldering around here. So again, you see there's too much solder, not enough solder, a cold joint, too much heat, and you can actually short itself. I'm going to show you first one of the boards we had a student worker working on that where he, if you can zoom in real quick, where he messed up a couple of times here on the board. So we were talking a bit earlier about how the solder wick can sometimes rip off pads and stuff like that, and you can actually see that here, where he put too much heat on there. There was too much solder, and he tried to remove it with the solder wick, and he pulled the pad off there. You can also see over here, this isn't flush. It's connected, but it's tilted. It looks like a little bit like a gravestone. And you can also see over here, he scorched another pad, and then probably like the worst one is here, where you can actually see underneath this wire here, whenever he went to go remove the solder, he tore out this trace here. And so to repair it, he soldered a very small, tiny wire to this pad over here to fix it. In some cases, you can do this. Not at all. So do be careful whenever you have to remove solder. It can damage your board, and it's just not, it can be a pain in the butt to deal with.
And this is why we have him practice on a board that we're not going to use.
Right. And meanwhile, we have over here one of the boards that we made ourselves down in one of our staff members at the electronics shop made. You can actually look very closely.
Josh?
Yes?
I would just recommend using the zoom on the camera rather than trying to hold the boards up closer to the camera,
Fair enough.
Okay.
because unless you're holding it perfectly steady, it goes in and out of focus.
Fair enough. Yeah, you can see here there's nice smooth ridges all the way down here, not all that much solder, and you can actually even look at these through-hole components over here, and they are nice little Hershey kisses, just like how we want it, all throughout the board. And then I also have over here beforehand, I went together and this is something similar that you'll have in your kit, and I went to go and try to mimic some of the bad soldering joints here, and this hurt my soul a little bit to make. But you can see here in this case, it's a very obvious case of way too much solder there. Could you actually zoom it in just a little bit more? So like over here, you can also see that is not as bad of too much solder, but it is still too much solder on there. Here's a decent soldering joint here. Over here, you can actually see that the board itself has been scorched. And that's whenever you've applied too much heat or you've left soldering iron on there too long. Over here, there's a case of where there's not enough solder here. There's just barely enough filling the pad itself. That's not a very solid connection there. And then over here, I managed to do a smaller short between two of the pads. And you can also see whenever it clears here, you can also see the solder, if you actually put too much solder, it will actually bleed through the board. And you can actually get these large solder clumps on the top, which can also cause problems. So this is just some examples of the bad and good soldering jobs that you can do as you practice this activity. So you should have in your possession a soldering practice kit as well as your miscellaneous parts kit. The miscellaneous parts kit, you should have this little bending jig that I mentioned earlier. And in the soldering practice kit, you should have either a old PCB board that has been cut in half where you can solder in components, or you should have a raw piece of perf board like this where you can solder in itself. So the very first thing that you do is of course, you turn on your soldering iron, and showing you real quick here, it is solid green, which means it is powering up and getting to the correct temperature. And then whenever it starts blinking, it means it's at the correct temperature.
Do you want to move that piece of paper to?
Yeah.
Yeah.
All right.
And bear with me as I autofocus and get to the right field of view for everybody to see it.
Yeah. So what I would recommend first is taking a resistor from your soldering practice kit and using your bending jig to bend it to whichever range you want it to be. So in this case, I'm going to do 0.6. Now, and you just bend it around the edge there so that it is nice and straight. Thank you. And then you can take it out of the jig, and then you can go onto your board and you can insert it into any of these holes. Now, because this is practice, the actual location of where you put it in doesn't matter so much. But if you're actually doing a real board, you can see that there's part numbers all throughout here. I'm actually going to go over here and put it in one of the resistor part numbers. And you want to push it in, and you want to get it as flush as you can. Now, in some cases, you might have some difficulty actually getting it flush. One of the techniques I know is if you have a pair of pliers, you can hold one end down, you grab the lead, and you can just pull it taut. And it'll be nice, and it'll be a little even with the board there. And then at the back, I tend to bend the leads away so that I can lay it down flat. And then looking at my soldering iron, you can see now it is blinking, so it is ready to be soldered. I take my soldering iron, keeping very mindful of where the tip is at all times. I grab my solder, which got moved right here. Put this back in here before I burn myself. And I uncoil a little bit of solder, and I'm going to tin the tip of my soldering iron here just by adding a little bit of solder. Here, let's go a little bit more. Sorry for all the refocusing, guys.
Yeah, we're trying.
I'm going to add a little bit of solder there. And then what I often do is I wipe it a little bit on my pad just so that it gets spread around a bit, but not too roughly so that it gets off. So you will have a nice shiny tip. And then what I'll do is whenever you go down to the actual board itself, you want to make sure that you are touching both the pad and the lead at the same time so that both get heat up. And then as it's touching, then you add in your solder until you get a nice clean joint. You don't want to add it on there too long, otherwise you'll scorch the board, and then you can take it away and you can examine the cut here. I'm going to take it out of frame for a moment to look at it closely with my eyes because it's kind of hard to see on the camera to see if I need to make any modifications to it. Which, that one came out all right.
That's pretty good, yeah.
And then you go ahead and if you're content with it, you go ahead and solder the other side, which I will in this case here as well. And then again, I do an inspection on there. And one thing you can't see on camera is every time I am done with my soldering iron, I put it back in its stand.
Here, I'm gonna zoom in on it.
And again, reiterating, you don't want to burn yourself. Take it from someone who has had solder burns before. It's not fun.
No.
And then whenever you're done with this, if you're content with your solders, you can make sure you have your pair of glasses on. And then you take a pair of level snips.
You want me to zoom out? Or...
Yeah. And then I often hold the lead here so it doesn't go flying, and then you just clip it off. You want to get it close to the board, but you don't want to actually damage the solder itself because that can cause issues, mechanical stress within the lead itself. But part of the reason why you want to hold it or and wear sunglasses is watch what happens if I don't. It can go flying somewhere, and that can go impale in someone's eye. And you don't want that to happen. You don't want to lose an eye. I don't want to lose an eye. Those are very important parts of our body.
And so at the end, you should see the lead. There's a little bit of the lead still sticking up through the solder after the pad and the solder. And so that's really ideal, but you want your leads to be short enough that they can't touch the next component's leads,
Yeah.
right?
So you can actually see here on this one over to the right here, it's actually very close to this other pad here. So in this case, I would go back and trim this just a little bit more, just so that you have a very clear, that it's not overlapping and touching there.
Yeah.
And in your soldering practice kits, you will have a number of different components. You'll have a capacitor, you will have some chips, you will have some loose wire, various kinds of components that you can then use and solder down to this board for various practice. I'm not going to go through all of the components here. Each one of them is very similar, but what I will do is I will do the wire, and I will do one of the chips here.
Yeah.
The wire, as you will notice here, is, if I can get it in frame, is there are multiple thin wires in here. This is a braided wire, multi-threaded wire. And this can be a bit of a challenge to solder at times just because the multiple threads themselves. And particularly with this board that I have here, this particular wire here is a bit too thick to fit into any of these holes. So it's not really ideal in this case. Instead, I will go and grab the slightly smaller gauge wire that will fit in these holes. If you try to put too big of a wire into a small hole, you're going to end up peeling off some of these braids, and that reduces the mechanical integrity of the wire, and that wire will eventually break. Now, this is also a risk with just these regular wires, especially if they receive a lot of mechanical tension, if they are being moved back and forth a lot. So just do be careful whenever you're directly soldering to the board. I highly recommend, if you're doing any circuit designs, that you actually use a connector of some sort rather than soldering wires directly to the board. But for prototyping's sake, and in some cases, it should do all right. So in this case, you want to just put it into one of these holes, which is kind of difficult.
You can send it to your computer.
Yeah, sorry. And then it goes through on the other end.
Okay.
Let me move this chip out of the way. All right, and you can see it's there. And what I'll also do is I'll tend to just bend it ever so slightly so that all the braids are going in the same direction. Then I'll lay it down.
It's
And
a little out of frame.
Fill out
You're
frame.
good. Yeah.
There you go. And then, oh darn it.
You're fine.
And then you just go in and you solder it. Same deal. You want a little bit of solder here. And with wire, as I repeated, it's a little bit difficult to solder it directly because of all these individual braids. There does exist solid core wire out there that you can use for these cases, but being a single strand in there, they are very susceptible to any kind of moving back and forth. It's as if the same kind of problem that you run into if you try to bend the leads of your resistors or your capacitors. If you bend it too much, it's going to snap. And then you'll have a broken wire, and that's just not fun. And then you go ahead and you snip out.
You're out of view.
You snip off the extra pieces at the end. And then you have a nice little wire sticking out. And then the last component I'll do here for you guys is a chip itself. Now these all have a little bit of extra technique for them. The ones that in your board, you might see that the leads themselves are a bit outward. This is normally how through-hole components are shipped. If you ever have to line them up, what often I'll do is I'll just lay it flat against the board here, and I'll just roll it slightly so that they're all in line so they can fit nicely onto the board. And then I will pay attention to where my pin 1 is, which there is if you look very closely, there's a little notch at the top here and a circle. Different chips will have different markers for the pin 1, but often this is what you'll see very often for marking where pin 1 is. And I'm going to go ahead and put it over here. I'm going to slide it in there. It can be kind of tricky because there's so many pins. And then it's it. And then you flip the board over, you lay it down flat, and then what I will often do is I will solder a single pin down. So I'll go ahead and solder this top right pin. I'll usually do one of the corners. I'll make sure it's nice and good, which this one looks all right.
Yeah.
And then the reason why I do that is then I can go back over here and I can check and verify that all these pins are in the correct spot. Now this is very important whenever you're doing surface mount design, like soldering surface mount components, because the chips themselves can shift around, and you want to make sure all of these pins line up. With through-hole, you don't have that same kind of problem often, but it's always good to double check and make sure, yes, this is where you want to solder the component, because as we mentioned in the lecture, once you solder more than 2 pins, it becomes increasingly difficult to remove it. So I'm going to go over here, and I'm not going to actually solder all of these pins here. I'm just going to solder this corner here. And actually, you know what? It doesn't take all that long. We'll just go ahead and solder all of one side. But again, reiterating, you want to double check and make sure that your chip is perfectly aligned and where you want it to be before you solder. Otherwise, I'll show you actually why you want to do that. Let's now go and try to remove this chip. So now, okay, we put the chip in the wrong spot. We have some problems. All right. So we mentioned in the lecture that we have two ways of removing it. We have solder wick here, and we have a solder sucker, which is a bit too big to fit within the frame here, so give us a moment. All right, and you see the solder sucker here. And we're first going to try to use the solder sucker here to remove the solder from the one pin that I soldered all the way over here. And you're going to see, you know, it's not always going to work out well. So you heat it up a bit, you put the solder sucker nearby, you hover it over, and you pull the trigger. And in this case, didn't really work all that well. The solder is still in the hole, and sometimes you'll have to do multiple applications of it, and you might, in the end, still not be able to get it out. Removing solder can be quite the pain, in which that case, it still didn't come.
Yeah, it doesn't work for me.
It doesn't really work.
Every now and then I get lucky with those things.
Sometimes you get lucky. And you can try to use the solder wick here as well, but as again, you can see, in this case, it's also very similar. Try to heat up the solder. You want to get the braid close, and you want to try to wick away that solder there, but it doesn't really quite catch so well. And so that's part of the reason why you don't want to just go willy-nilly and solder ICs into the board. Now I actually do want to actually successfully remove something and show you a case where solder wick or a solder iron would be useful. So I'm going to bring back my old board that I showed over here. And you see this nice big blob that we here. That's a good contender for actually getting rid of it with solder wick here. As we mentioned, whenever we put it on here, it's kind of hard to actually get the solder to initially melt, but if you hold it down long enough, it will eventually melt. If it doesn't do that, you can add a little bit of solder so that it starts melting quicker. And then in that case, you bring it in, you try to get as much solder as you can attached to the wick, and then we got a decent little bit off there. There's still some more there, and so you can rinse and repeat until you get as much solder as you can out.
So I actually add solder at this point.
Yeah. And yeah, decent bit there. And so that's the case where the big blobs where you may not have to add any. But over here, for this one where I'm going to wipe my solder tip off here to get rid of some of the excess solder that got attached to it. And I'm also going to trim off this edge of my solder wick here so that there's no more solder on it. So I have some fresh, clean wick instead of this one that's covered in solder that may not be so good at getting rid of more solder. But this one over here, there's not all that much solder on there, and I just really want to get some of the excess solder off. And so what can be helpful is adding a little bit of solder here so that we can get more solder off. And you want to be careful with this because the wick itself does get hot. It is metal. So you want to be careful where you hold it. It was starting to get warm where my finger is, and I'm holding it a good centimeter away. You sacrifice a little bit of dexterity when it's farther away. Just be careful, watch your hands, and watch again, very importantly, where the solder tip is. So those are cases whenever a solder wick is very useful. And then on here, actually, I have a single spot here where there you can, I actually soldered a single lead into it by itself. And that's actually a case whenever that would be actually decent for for being removed by a solder sucker when you have a single spot like that. So in this case, we want to heat it up. Hopefully this works on the first go. And look,
Oh, you got it.
it got it. There's a little bit of solder here, which that's okay. There's going to be solder that's going to be edged around the entire hole. You're not going to be able to get all the solder away, but you can get most of it. And then an important thing afterward, you plunge your thing out, make sure you get the nice little bit of solder that you removed, and you go and you toss that away. They have a bit of a spring to them as well. And that really is the basics that you need to know when it comes down to soldering. There are a couple of other things that you can do afterwards. You can clean the board using alcohol to get rid of some of the excess flux on there, which in that case you will want to use one of these like brushes like this, and you can use what I have here is some isopropyl alcohol, and you can squirt a little bit on there wherever the solder is, where the flux is. And then you just kind of scrub away at it, trying to get some of the flux off. And it's got a decent little bit. You got to sometimes scrub a decent bit here, but just showing you some of the flux removal techniques. This can be very helpful in keeping your boards clean, neat, and tidy. There's also some techniques for soldering wires to wires. I'm not going to go through that here in this case because it can be difficult.